All right, ladies and gentlemen, so today we're going to be working on actually calculating some probabilities. And we have some new vocabulary that you're going to see. And one of those is something called with replacement. And with replacement means that if I take something out, it's going to be put back before I pick again. So the item is returned before a second pick. Okay, we're also going to talk about theoretical probability, and theoretical probability is what should happen. Meaning that, let's say I was flipping a coin 50 times, I should get half of them heads and half of them tails. But that doesn't necessarily happen if you actually go through and flip the coin. So today we're going to be talking about theoretical probability. All right, let's just get right into some examples then. So create a sample space, which is what we worked on yesterday, to show the outcomes for flipping two coins. So my outcomes can be, right, I can get heads on the first and tails on the second. I can get heads on the first and heads on the second. Now, for the second, or I can get tails on the first, heads on the second, or tails and tails. So there's four things that can happen, because those are being kind of put together in groups. Then I want to know, well, what's the probability that I get two heads? Well, I have four outcomes altogether. One of those shows getting two heads together, so 1/4. If you wanted to turn that into a percent, you could say it was 25%. Probability of getting a tail. Well, I still have 4, but it's saying any time that I see a tail is in one of my combinations. So there's 1, 2, 3 of them, 3/4. And again, some of you were asking about being able to turn those into percents, so that would be 75%. All right, let's see what's up here. Consider the chance experiment of rolling a number cube. What is a sample space? So we're going to assume it's a normal number cube, meaning a die. So we have 1, 2, 3, 4, 5, 6. List the probability of each outcome in the sample space. So for a 1, 1/6. 2, it's 1/6. 3 is 1/6. 4 is 1/6. Right, they're all 1/6. What is the probability of rolling an odd number? Well, I have 3 odd numbers, so 3 out of 6. You could reduce that to 1/2. You could write that as 50%. What is the probability of rolling a number less than 5? So less than 5 means you can't count 5. So we have 1, 2, 3, 4 of them. 4 out of 6, or 2/3, or 66 2/3%. All right, next one. Consider an experiment of randomly selecting a letter from the word number. What is the sample space? N, U, M, B, E, R. Right, and I know Mr. Bush put those into set notation with the fancy brackets, but I'm not going to do that. So what is the probability of selecting a vowel? There's 2 vowels, and there are 6 letters altogether. So 1/3, or 33 1/3%. What is the probability of selecting the letter Z? Well, there aren't any Z's. So that's supposed to be a 0 out of 6. All right, hopefully not too difficult here. Oh, look, that's practice already. See how easy that is? So it's just kind of looking at using things that are with theoretical probability, which is what should happen. And we're going to compare that with experimental probability a little bit later. But any questions, as always, bring them to class. Hopefully you find this nice and easy. Have a good night, guys.